I'm Anil Kumar, and in this video we will understand reflection of a graph on y-axis. The question here is, if f of x equals to 2x minus 1, write an equation to represent y equals to f of minus x and describe the relations between the two functions, right? So that is the question for us. Now remember, in earlier video we have taken y equals to minus of f of x, where the result was reflection on x-axis. This time it is kind of different. So you can actually pause the video, answer the question, and look into my suggestions. Okay, so what we're given here is that the function f of x is equals to 2x minus 1. Now what is f of minus x? It really means change x to minus x. So we get 2 times minus x minus 1, or we could write this as minus 2x minus 1. Do you see the change? So f of minus x is very different from what f of x is. Now we already have the function f of x, which is 2x minus 1, graphed here. So this point is minus 1. Let me write down this point as minus 1. And then slope of 2, that means the next point at 1 is 1. So this is 1, 1. And then next one also increases by 2 times. That is the meaning of slope, right? So 2, 3. Similarly, if we decrease both the things, then we get at minus 1 it is minus 3, and at minus 2 it is minus 5. So these are the points on the function f of x, correct? So it's a line which extends both sides. Let us find the coordinate points on f of minus x, right? So we'll do some calculations here. So I'll write down the x values and calculate f of minus x, which is minus 2x minus 1, correct? So let me start with minus 2. So if x is minus 2, it will be minus 2 times x value is minus 2, right? Minus 1. Minus minus makes it positive. Positive 4 minus 1 will give us 3, right? Minus 1, that means minus 2 times minus 1, minus 3. So that is 2 minus 1, which is 1. For 0, this is 0. So we have minus 2 times 0 minus 1, which is minus 1. For 1, it will be minus 2 times 1 minus 1. Minus 2 times minus 1 is minus 3. And for 2, minus 2 times 2 minus 1 results into minus 5. So the coordinate points which we have are, so we can write that the coordinate points for x and y in this case will be minus 2, 3, minus 1, 1, 0 minus 1, 1 minus 3, and 2 minus 5. Correct. Let us plot these points. So minus 2, 3. So for minus 2, we have a point which is 3, that is here. You can see it is reflected on y-axis. Do you see that? So minus 2, 3, x value has changed to minus, and it is a reflection on the y-axis. Correct? So that gives us a point which is minus 2, 3. The next point is minus 1, 1. So minus 1, 1 is here, and this also is a reflection on y-axis. Do you see that? The x value changes to negative, y remains same. So this is minus 1, 1. Similarly, the other points, 0, minus 1. 0 minus 1 remains at the same point, that is the y-intercept. This is invariant, right? Then we have 1, minus 3. At 1, the value is minus 3. So we get a point here, and this point is also reflection on y-axis. Similarly, the other point should be reflection on y-axis also, and we do get point which is 1 minus 3, and this is 2 minus 5, correct? So what we observe here is, first thing to observe here is, for this function, reflection on y-axis, right? So we sometimes say horizontally. This is all horizontally happening. So whenever we have something inside the brackets, it is horizontal in nature, right? So this is horizontal kind of thing. Is that okay? Now when this reflection happens, what really happens to coordinate points? So original points, let's say x0, y0, will now change to x values become negative. Do you see that? Those are the new points, x, y. So that is a kind of transformation which takes place. And this kind of transformation results into changes in the characteristic of the graph, correct? So now let me join these points and sketch the line. We do have one invariant point, and that point is indeed, as expected, the y-intercept, correct? So that's line for us is minus f of minus x, correct? So that is the line. Okay, so the other changes which we have seen is invariant point, and that point is y-intercept. So y-intercept is invariant. That means no change, right? That means no change. It does not change. So for us, the y-intercept was 0 minus 1. So 0 minus 1 changes to 0 minus 1. Now you can understand plus and minus zeros are same. Right? It makes sense, correct? Let us now look into the characteristics. So what happened to the line? Earlier we had a line which was rising, correct? So we had increasing intervals. So increasing became decreasing, right? So it kind of reverses as far as the trend is concerned. So it reverses, right? And we see that since this is a line, there is no change in domain and range, because the domain and range are both real numbers, but there is change in end behavior. End behavior changes. So the first line in f of x was from quadrant 3 to quadrant 1, but f of minus x is from quadrant 2 to quadrant 4, right? So that is a major change. The end behavior reverses, changes. So that is the change which we see. So these are two mirror images, and the axis of symmetry here is the y-axis. Since y-axis is axis of symmetry, we will observe that both the graphs will be congruent. So we will produce always congruent graphs. So these are a few changes which you will see when you're considering or comparing functions f of x and f of minus x. We say f of minus x is a function which is reflected on y-axis, right? So since it is reflected on y-axis, the domain may change. The range will not change. X coordinates will change from x to minus x, but y coordinates will remain the same. I hope with this you have got good concept of how functions reflected on the y-axis can be graphed and characterized. We'll take a couple of more examples regarding the same. Thank you and all the best.